Our next speaker is Viven Sharma from the Earth and Environmental Sciences Department, and I'll ask you soon to prepare for the next talk.
Hello, my name is Viven. I'm a fifth-year PhD student at the Earth and Environmental Sciences, and what I work on is geodynamics. So we as geodynamicists use computer models, which I'm showing on the right here, for example, aspect, to analyze the Earth system processes. What I'm doing or what I'm showing here is that the LLMs, such as the foundational LLMs, could be used and could be trained to learn the behavior or the understanding of the code, such as aspect, and we can accelerate the process of learning and code generation and model setup in these scenarios. For example, for those people who are working in CFD, CFD mostly deals with the Navier-Stokes equation, and here the aspect which I'm showing here is a computer model or a software which is related to Stokes equation, which is quite close to the Navier-Stokes equation with certain conditions. So what we do is we use DeepSeek Coder V2 model, which is a 16 billion parameter model with 128K context window. We train it on the documentation parameter cookbook and the source code examples. And as the LLMs are powerful in themselves, it is able to learn the behavior on the understanding of how to set up the model, how it behaves and stuff like that. And it is, again, most of the LLMs are based on the retrieval augmented generation setup. So you give a query, it doesn't take that query itself, it modifies that query based on the information it already has, and gives the LLM an modified prompt, which is able to give you a better comprehensive answer in itself. So that's the idea, and here are the results. So what we do is, I haven't mentioned it here, but it's a 2D Stokes equation model. And in the first panel, I show the results with code writing tests. So we give it a prompt, and it compared to the other standard models, our model is directly, performing better in all of the aspects. For example, BLUE score, compilation, comparison, and also the physics understanding of how the model behaves. Likewise, for the code debugging test, we set up a particular code, and we synthetically added a few bugs in it, and then asked the model to remove those bugs. And I just want to mention that all of these results are an average of over 10 simulation setups. So we ran all these setups multiple number of times to be able to get an average result from these. So that's all I have. Thank you so much.